A few years ago, two dedicated software engineers spent 18 straight months working on a single massive problem. They were trying to build a program that could recognize human faces in photographs. Specifically, they decided the best way to make the software smarter was to write complex math that would automatically cut out the background of every picture. They wrote incredibly intricate code. They even published a research paper on their findings. But when they finally plugged their year and a half of work into the main face recognition program, the system's overall accuracy improved by only a fraction of a single percent. That is a lot of time lost for almost zero reward. It is incredibly common in software development to spend massive amounts of energy fixing the wrong part of a problem. But if we learn how to properly diagnose our systems, we can avoid this trap completely. To understand how to diagnose a software issue, we first have to understand how these systems are built. Most complex software is structured as a pipeline. This just means taking one massive, difficult task and breaking it down into a sequence of smaller, step-by-step chores. Think of a commercial bakery making a cake. Step 1 is mixing the batter. Step 2 is baking it in the oven. Step 3 is applying the frosting. If the oven is broken, it doesn't matter how perfect your frosting is. The final cake is going to be a disaster. Machine learning works in the exact same way. When an artificial intelligence system makes a mistake, the engineers have to look at their sequence of steps and figure out exactly which specific chore is causing the bottleneck. If you just guess which step is broken, you end up like those engineers, wasting 18 months on the equivalent of mixing better frosting for a broken oven. To avoid that, developers use a mathematical system to know exactly where their effort will actually matter. Let's look at a new example. Imagine we are building an app on your phone that takes a photo of a street sign in a foreign country and translates the text for you. We can build this app as a 3-step pipeline. Step 1 finds where the words are in the photo. Step 2 chops those words into individual letters. And Step 3 actually recognizes what those letters are. Right now, our app is struggling. When we test it, it only reads the signs correctly 72% of the time. We have a small team and a limited budget. Which of these 3 specific steps should we spend our time trying to improve? This is where we use a technique called ceiling analysis. Instead of writing new code, a human engineer steps in and manually feeds the computer the 100% perfect answer for just the very first step of the pipeline. For our translation app, an engineer would sit down with our test photos and use a mouse to manually draw boxes around all the text. We are temporarily faking a mathematically perfect text detection tool to see what happens. This chart shows the results of our test. By giving the computer the perfect answers for Step 1, marked here by the red check mark, the overall accuracy of the entire app shoots up from 72% to 89%. That 17% jump is our ceiling. It represents the absolute maximum improvement we could possibly achieve if our team spent all their time creating a flawless text detection feature. Next, we run the exact same test on Step 2. We manually give the computer perfect outlines for every single letter, faking a flawless character segmentation tool. The results here are incredibly revealing. With a perfect Step 2, our total system score only rises to 90%. That is just a 1% gain. Without this test, we might have guessed that character segmentation was our biggest issue. Ceiling analysis mathematically proves that spending a year on that step is a trap. It directs our efforts strictly to the tasks with the highest possible yield. Let's go back to those two engineers from the beginning, the ones who spent 18 months trying to recognize human faces. This diagram maps out the actual steps of their face-reading software. Their pipeline started by taking the camera image, removing the background, and then detecting the face. Before writing any new code, their overall system was working at 85% accuracy. If they ran a ceiling analysis, they'd manually scrub backgrounds from test photos using Photoshop. The math shows the hard truth. Even with a perfect background remover, the system's accuracy reaches only 85.1%, an improvement of just 0.1%. If they had tested the very next step, face detection, they would have seen a potential jump of nearly 6% waiting for them. Gut feelings are unreliable when building complex systems. Ceiling analysis removes the guesswork, giving you the mathematical proof you need to ensure you never waste a year of your life solving the wrong problem.